Even up there.
Bill, or then anyone that wants to run the camera.
Okay.
Follow the person.
Oh, is that why it zoomed in on you when you?
Yeah.
Great, so we still got about 10 minutes here. If you haven't signed in yet, feel free to do so there. We're only asking for email if you want an email copy of the questions, comments, suggestions after the meeting. So we will be taking notes. You won't get that email until Monday because we're closed tomorrow, but that's just for your information if you want it. We do have agendas up here as well if you would like. This meeting is being live streamed. And at the beginning of the introduction, I'll go over public comment and how that's gonna work. And then, yeah, we'll get started here in about 8 minutes. If you need to use the restroom, it's right out this right door here. Turn to your right. There's a ladies and a gentleman, okay?
Hi, guys, is this somebody
All right, everybody. Thank you for joining us today. So today is our public information session. So it is not a meeting, so it's not going to have that typical setup. But we do have just a little agenda kind of to keep us on track. So first off, I would like to introduce Mr. Tom Sutton. He is going to be our presenter today, just to give you guys an insight into what these systems are. So again, this information meeting is strictly on the battery energy storage systems. It's not necessarily about the ordinance or the adoption or what goes into the ordinance. So if you have any questions about those, we'll keep those for a later Board of Commissioners meeting. Today, we're going to ask questions related specifically to these systems, whether it's how they're created or operated, that type of thing. So Mr. Sutton is going to take the time to walk us through his presentation. Over the last 4 months, I've collected the questions, comments, and suggestions related to these systems. And I will be asking him those questions that were raised. At the very end, there will be an opportunity for the public to come up and then ask their questions. We do ask, because this is live streamed and Zoomed, for people who aren't able to attend in person, that when you do have a question, that you come up here and you can speak into that microphone. You don't necessarily have to say your name or where you live, that kind of thing. It's just so that we can hear you, and then anyone who's watching can also hear you. I mentioned this earlier, but this meeting will be live streamed on YouTube. And then the recording will be uploaded to the Board of Commissioners YouTube page on Monday at some point. So we are closed tomorrow. But it will be up there Monday at some point. So if you wanted to go in and view it later, or if you had questions about something, or maybe you missed something, you wanted to re-review it, you can. So there are 2 rooms. We do have public flow upstairs, and it looks like it's currently empty, but on the off chance that people start showing up after work and they do go up there, during public comment, we'll have this room go first. And then once everyone has finished with their questions here, we'll ask them to go. Just kind of keep it organized, and that way no one's talking over one another. Okay? All right, thank you much.
Thank you. Welcome. Thanks for attending tonight. My name is Tom Sutton. I'm the owner and the president of Sutton Technical Services Incorporated. My company specializes in custom electrical equipment design, primarily for training technicians. We also, as part of our portfolio, do a lot of technical consulting, and we're really heavy into the workforce safety training and standards developments. As part of that, I spent 22 years as a paid-on-call firefighter. And so I personally, through the company, like to go out and do the fire department orientation and trainings for those communities that are having battery storage systems installed in their municipalities. And so what I was asked to do and invited to do tonight was to give you an overview, and we can have some discussion opportunities about what battery energy storage is, why it's being deployed around the country. We can talk about, lessons learned in the past and where the technology is today. And then I'd be happy to have, some questions and open discussion at the end too. Okay. A little bit more about me. I spent 16 years in the college system at Kalamazoo Valley Community College, where I built, developed, taught, and administered the wind turbine technician hands-on training program. I still currently do a lot of work with the fire service in the technical rescue realms of high angle and confined space rescue training. So I'm one of their advisors that gets deployed on an incident. Our company specializes in turnkey training solutions for employers that really want to keep their employees safe, especially in power generation. And it's all forms. It's not just solar or wind. We'll provide them the custom equipment, the curriculum, the validation materials, and all of that. So let's move into it. It's a short presentation. It's really designed for fostering discussion. I know we have some questions that have previously been asked in public comment, so we're going to try to address some of those as we move through this. Brief agenda for this is going to be, I'm going to talk about what battery energy storage is, typically where it's deployed and what the equipment looks like. I'm going to spend some time talking about the new requirements around design and safety systems in these that came about because of lessons learned from the past. So we'll do a little case study, past versus present, and then that should leave plenty of time at the end for questions and answers from the public. So, the big question is, what we're here to talk about tonight is what is battery energy storage and where are we finding it? Well, it's kind of interesting because we're here talking about utility scale stuff, but we also see battery storage and rooftop solar installations when somebody wants to install panels on the roof of their house. And generate their own electricity. That does end up in a storage battery somewhere. Typically, the popular ones currently are like Tesla Powerwalls and some of these really high-tech lithium-ion battery systems. They look like great big marine batteries. And the challenge with that is, across the state, across the country, every county could have different rules and regulations from their building departments, electrical and so on. And so when I was a firefighter and we had these systems, there's a few of them in my jurisdiction, our big fear was we don't know anything about those. We don't know where the battery storages are. We don't know where the cables run. We don't know if it was a do-it-yourself project or so on. Versus the utility BESS, which is commonly co-located with things like solar parks, wind farms, sometimes both. Other countries are even phasing out their fossil fuel plants and removing that infrastructure and putting battery systems where the plant used to be because the interconnections are there for the grid already. So we're seeing utility scale being deployed not only around our country, but around the world. And sometimes I get asked, how much battery storage is already here? I mean, it's new, right? It's new to us. Well, there's actually tens of thousands of megawatt battery hours already installed all the way across the country. I am nonstop traveling to fire departments across this country, doing the training for fire service people and first responders. They're going up everywhere, coast to coast. And ultimately, the purpose of a battery storage system is to allow electrical energy to be stored. It can then be used later. Think about your flashlight. Keep a spare set of batteries, right? Got bad weather coming tomorrow, right? Check the batteries. That's a storage unit. That little battery that you use in your flashlight is a storage unit for electrical energy. It's designed to hold it there until I need it in my flashlight or my radio. Same thing with battery energy storage systems that we're talking about tonight at the utility scale. It's designed to store energy that can then be deployed later. Historically, our electrical grid has had no ability to store electricity. The electrons that were generated microseconds ago to light these lights were literally generated microseconds ago and have to be used almost at the same time. So if you start to think about what happens if the sun is really shining brightly today and I've got more power than I can possibly use because we have to match generation to demand, well, we'd have to disconnect. That's not an efficient use. Wind turbines, we'd have to shut them down if it was overly windy. Gas-fired fossil fuel plants, there's a couple of ways that they can turn down, but it's not easy. One is turn the fire off and let the water cool if they're using steam, or vent the steam away, therefore wasting all of the energy we use to heat the water. In a gas-fired plant, if they start to shut down the gas and reduce the speed on the turbines, that's very damaging to those super expensive systems. So what we have the ability to do now on the grid is to have a place for that extra electricity to go and save it until we need it a little bit later. Does that make sense? If this is why, I went on this morning to update this particular slide. The graphic that you're seeing there is a screen scrape from MISO Energy's dashboard. MISO Energy is our grid. It runs from Manitoba all the way down to Louisiana, New Orleans. And so everything in that footprint, you can kind of look at like as a bathtub for electricity. There's generation sources pouring it in, and there's consumers taking it out all at the same time. And what you see these three lines to represent, the darker line that's kind of towards the bottom of the three, that is what the grid operator forecasted for today. The lighter green line is the generation that they were able to secure, and they always try to secure a little more generation asset than they think they're going to need, just to be on the safe side. Now, the gold line, the yellowish line where the arrow is pointed, that's the actual demand. And when that is above cleared and predicted, guess what? We have a shortage. That's a problem for the grid. That's a problem because it puts wear and tear on the grid. Years ago, California, you heard about brownouts, rolling brownouts. They were doing those rolling brownouts and rolling blackouts to try to save the infrastructure because there was way more demand than they had generation for. This is where battery energy storage can shine, because the battery energy storage system can be turned on and off to give power back to the grid almost instantly. It's very, very fast. And so as soon as we see demand exceed what we've already predicted and cleared, the battery can come online to supplement that over short periods of time, therefore making the grid more reliable, our electricity that we get into our household better. We're not seeing our lights flicker and dim down and things like that. And so that's why battery energy storage has become such a topic around the country. Because let's face it, we are electrifying like never before. Who owns a battery operated lawnmower? Couple of hands. Who has an electric vehicle? Nobody yet. There's 3 of them on my street now. They had to upsize my transformer. Excuse me? Hybrid, yeah. That's another technology that's out there. I've done some work with hybrid with Ford in a previous career. So as we add more and more demand for electricity from the grid, we have to, as a country and the regulatory bodies, they have to understand, where is that generation coming? It just doesn't appear. It takes years to permit and build big power plants, and it takes years to build these kinds of projects. And it takes a lot of money. And so it's not something that I can say, well, we're short today, let's build something for tomorrow. They actually have to plan these out over years. In some cases, like nuclear, it could be a 30-year process. And if we look at the larger picture, this is also a screen scrape from the dashboard. This was at like 9 o'clock this morning. Now remember, it is from Manitoba all the way down to Louisiana. But the green and the yellow, green is wind and yellow is solar. This is the fuel mix that makes up the 69,000 megawatts of electricity being consumed in our footprint at that point in time. And it tells us what generation sources are contributing and how much. And not just 10 years ago, you wouldn't have even seen the yellow. And the green would have been a fairly small tick on this big circle. What do you think would have been the largest components? Coal and natural gas were number 1 and number 2. And they're slowly starting to shrink now across the footprint as more and more wind and now solar are being installed. And battery energy storage, I'm going to start calling it BESS for short. BESS plays really well with those kinds of resources. And what it does then is allows the fossil fuel plants to set a base load that's predictable. And they can actually reduce fuel levels a little bit because wind and solar also have to forecast how much power they're going to give to the grid. And so they can start to reduce their base loads using less fuel. And they're not having to make emergency decisions and change their load at a drop of a hat, right? Which is bad for their equipment. And so BESS is that magic piece that we haven't had up until now, or in recent history, I should say, from about 2000 on, that allows us to take extra energy, store it, and then put it back on the grid when we need it. And battery energy storage, it isn't used typically as a standalone thing for the power grid. It's usually combined with solar, wind, a substation that already exists with a tie line going out to the grid. And it becomes a part of the asset that's used to put that power out onto the grid. And you can see here, it sits off to the side. It also has some inverters, a transformer, some switches. And we'll talk a little more about those, but it also is remotely monitored and controlled, and that's law. They have to have 24/7, 365 system operators on anything that's generating electricity to the grid. Not something we can just plug in and walk away and not look at it again. So it's being monitored continuously. And that's going to be real important here later when we start talking about the new standards. Sometimes I get questions about, well, what happens if we lose communications to it and they can't control it? One of the things that is done is called ring topology. And what that means is the battery containers have to have separate means of communication. So you can see in this diagram, there's two switches and there's two pathways. So even if one pathway is eliminated, the other pathway still exists for command and control. This does allow for remote control and disconnect, even if one of those paths were to become compromised. So the two components that primarily go into a battery storage system are the inverter on the left and then the battery storage units on the right. Now, this is not a one-to-one relationship. One inverter will actually be responsible for several battery units. Okay. And the inverter is actually talking with the battery, and the battery is telling the inverter when it can take charge and when it can't take charge from the grid. And you can kind of see the little water tank on the left moving up and down, and there's a spigot on there. Well, basically, the battery and the inverter each have control systems that are talking to each other. And if the battery says, hey, I'm sitting at 30% of my capacity, and the inverter says, well, hey, I got a whole bunch of electricity I can't send anywhere. Can I send it to you? Yep, send it my way. Opens the valve, puts a little bit of charge into the battery, closes it off. Later on, the inverter calls the battery and says, hey, I got more demand than I can have production for. Can I have some of your energy? Battery says, yep, opens up the valve and it gives some of that energy back that's been stored. That's a simplified way in how it works. In the middle, you can see the battery, the inverter, then there's a transformer, and the transformer is there to step the voltage up to make it the same as whatever the tie line is into the grid. But the battery and the inverter, those are what are working together. And the National Fire Protection Association and the International Fire Code play a huge role in how all of this can be put together and deployed. We're going to spend a little more time talking about that, but NFPA 855 is the standard from the fire service that dictates storage battery systems. The batteries are capable of giving energy out over time. So you can see here on the left, the battery has a watt-hour rating, that's the quantity, and then it has a power rating, that's how long it can provide that quantity over time. And so, for example, 1 watt of power for 1 hour would equal 1 watt-hour of energy. Most battery storage systems, or the container itself, is somewhere between 4 and 6 million watt hours. And it can deliver that over about a 4-hour period continuously before it hits the point where the battery tells the inverter, I'm sorry, you can't have any more, I'm tapped out. Now, it doesn't charge that fast. It takes much longer for it to recharge because we don't want to push charge into these batteries fast because that can lead to bad things. And so it'll take somewhere between 10 to 16 hours typically to bring the batteries back up. And this is kind of a simulated view of what an installation looks like. Now, keep in mind that when we deploy batteries and inverters in the industry, the batteries and inverters aren't scattered out throughout the solar cells or the wind towers. They are usually co-located in an enclosed yard, very much like a substation, and sometimes they are part of the substation. And all of the power from the solar panels or the wind or whatever it is come in through the collector circuits into that controlled area where all of this takes place. And again, that system is being remotely monitored and controlled 24/7. You can see the little yellow box there. That's the system operator's interface into the EMS, which is the electrical management system for the whole installation. Any questions up to this point that you want to address before we move on into like the battery construction and what's inside and standards?
I think most of the questions that pertain to you will relate to what is actually inside. One of the questions that they did have was what's the current standard for safety and or fire suppression for these systems?
So there's several standards and we're going to start to break those down as we go through. So that's a great segue into this next topic. So the typical system components and how they're integrated, we'll start from the left side of the screen. We have the battery cell, and these cells are typically the size of a textbook, a large textbook. So think back to school, you know, the biggest, baddest textbook that you had that you hated to put in your backpack, that's what this looks like. And then these individual cells are typically about 3.5 volts of DC electricity each, and somewhere between 100 and 500 amp hours of capacity. And that cell then is taken and put into a module configuration. So the next picture to the right is the module. Now the module contains sensors, instrumentation, controls, cooling systems and plates, covers, and thermal barriers. All right. Once the module has been put together, then they take those modules and they move to the right and they put them in a rack. And the racks are typically where we see our 1,000 to 1,500 volts of electricity, depending on the configuration. And at this point, it has to have what's called a BMS. That is a battery management system. That's a computer system that's designed to take care of that battery and proactively prevent bad things from happening. And this is where we also incorporate the protection and the safety devices for the battery unit. Those racks are then moved over into the battery container that you see at the far right. And these are outdoor rated, they're sealed, they're self-contained units. They'll have things like cooling system, HVAC type stuff in them, ventilations in case of an emergency. We'll talk about that in a minute. They're between 4 and 6 megawatt hour capacities, and they're the size of a 20-foot shipping container. And they're not going to be bigger than that in the foreseeable future because of shipping weight limits. They're heavy. You know, think about how heavy batteries are. So they're typically going to stay that 20 by 8.5 by 9.5 feet. Self-contained unit. The total system then includes your containers, your BMS, which is your battery management system, your TMS, which is the thermal management systems, the FSS, which is the fire safety systems, and then you have your power controls, your inverters, and your transformers. In previous years, and I'm talking prior to 2020, we did see what's called a walk-in battery container. So you can, as it sounds, the technicians would have to go inside of this container to do their work. And for my friends in the fire service, that's an occupied building, right? That has some life safety codes around it. And we're going to look at a case study here shortly about a walk-in container and why most developers will not use walk-in containers anymore. They'll use the non-walk-in container, which is what you see up here. And there's a few reasons for that. One of them being we can environmentally separate it from the environment outside. It's a self-contained containment system. It's designed to deal with its own emergency, contain that emergency, and when the event is over, the operator of the system can literally take that that battery module away, send it to the recycler, and they can put a new one in its place. There's no cleaning up stuff. There's nothing that gets out. Unlike the days of old. Internally, nowadays, everything from 2021 and on has to comply with NFPA and UL certifications. So we're going to start into the NFPA. NFPA says you have to have fire detections and notifications. So this is NFPA 855. Each of these battery modules have their own fire alarm control panels. They have smoke detectors, gas detectors, manual pull stations, independent backup power supply for the fire panel and system, as well as horns and strobes on the outside of the container. Now, if you look to the right, NFPA says you have to have deflagration control, and there's two ways to do it. There's NFPA 68, which it's what they call panels. So if we think about other industries that have explosive potentials, they would have sections of walls that were designed to blow out and direct the force of an explosion. That is a way that it can be done. And if they're going to do that, they do it on the top of the container, and they're hinged damper doors. So there's nothing flying off of these things. The door will open up automatically as the pressure reaches that calibrated level. It'll vent and then it closes, because we don't want anything open to the atmosphere. What if it's raining that day? Water and lithium don't play well together. So we make sure that that's sealed. NFPA 69, however, recognized the limitations to the deflagration process and said, there's a better way to do this. So the picture at the top right is where we have controlled louvers for inlet and outlet, intrinsically safe blowers. And those will actually come on when it detects 10% of the lower flammable limit of a gas. We'll open the louvers, it sends alarms to the monitoring center. It starts to vent what it needs to keep it below 25% of the flammable limit. Uh-oh, you got to run? No. Okay. I know that sound.
Tom,
Yes.
you're talking about vents and talk about venting.
Mm-hmm.
What kind of gases can we expect to be released out of those vents?
Under normal operations, nothing. If there is an event, then we're going to see the typical products of combustion in a plastics fire. So your carbon monoxide, your hydrogen side, all of the stuff that we see in a typical house fire nowadays, quite honestly. The only difference being is because there's small amounts of electrolyte, there's like HF, we can see a little bit of hydrogen fluoride in there. But again, it's at 10% of the lower flammable when it gets rid of it, and then it shuts off, right? As soon as it gets below 10%, it shuts off. Says, no, I'm going to keep what I have. I don't need to vent it. I'm not in danger. But this is only in the event of an emergency. Something has gone wrong. Under normal operations, there is no discharge of any kind of chemical.
Okay, so
Yeah, they don't offer.
a normal operation, then I would understand that those louvers would open up to let ambient air in and out, so just to control the whole system. Is that how that's going to work?
It can,
Or
yeah.
You said something about air conditioning.
Yeah, typically they have a separate ventilation system for thermal management, for temperature, temperature and humidity.
Right.
These systems for deflagration are only in the event that a thermal runaway event or something is happening inside the battery, that it needs to get the pressure out of the container.
Okay,
Okay.
I'll ask more questions down the line, but
Did that answer it?
well, Bonnie back there shaking her head, that's not gonna happen, so. I see her saying no.
So I promised you a case study. So about a little over 5 years ago, there was a battery storage facility in Surprise, Arizona. And it had an event, it had a thermal event where it was what they call thermal runaway. It was producing its smoke and its pressure and everything like that. The fire department responded. 4 firefighters suited up, they went in, and the first thing they do is what every firefighter is trained to do. Go to the source, put it out, right? They opened the door and they introduced a large amount of oxygen into a walk-in container, and there was an explosion. And they were severely injured. This was a paradigm shift moment for this industry to say, look, we cannot have this happen again. What do we need to do? And so the first thing that happened is a third-party certification and quality assurance company called DNVGL was brought in to do a full investigation, and they issued an 87-page report. We're not going to read that tonight, don't worry. But there were 5 key takeaways from that. The 5 contributing factors that they identified in that incident were the internal cell failure initiated a thermal runaway. What resulted from that were beefed up standards under UL 1973, which is storage and mobile electrical batteries, and UL 9540A, which we're going to go into depth on, which is the testing methods for live burning these things to prove that the systems would have worked. They didn't have any of that before. So modern BESS now has improved manufacturing and safety testing processes. They can't just say it's going to work, they have to prove it now. Another contributing factor was the fire safety system wasn't able to stop the thermal runaway. It moved from one rack to the next rack to the next rack to the next rack until it got outside of its container. So NFPA stepped up to the table there and said, well, we can put some standards together that say you've got to stop this thermal propagation from one rack to the next to the next. And so NFPA 55 was updated. And again, UL 9540A incorporated the tests to prove that it wouldn't propagate from rack to rack. And so now modern BESS system designs have to undergo very rigorous testing and mitigation measures to prove that these systems can stop that thermal runaway. Another factor was the cascading thermal runaway due to the barriers. So like I said, it propagated throughout the container. It had flammable gases accumulated. They had no ventilation provisions to get rid of the pressure. So it was just sitting there waiting for somebody to open the door. And ultimately, there was inadequate operating procedures for the emergency response planning. So you can see in the middle there, the standards that were directly either created, updated, or developed around those key factors. And then anything after 2021 has to have all of that incorporated into it now. There were some additional lessons learned out of this too. One was it was a walk-in enclosure. If it hadn't have been a walk-in enclosure, there wouldn't have been a need to open anything to go in. So most projects now mandate non-walk-in style containers. Another lesson learned was the on-site personnel weren't available to do what they needed to do. They didn't have the remote capabilities. So they had to wait for somebody to get there. Nowadays, projects are able to be controlled remotely. And then there was an over-reliance on the suppression system. They thought that, well, we got a suppression system in there, that'll take care of it. It didn't. What it did actually made the situation much worse. So for those of us that have been around fire, like if we have a natural gas or a propane fire and it's on fire, we want to let it burn until we know how to secure the fuel source, right? We don't want to put the flame out, because then the gas is still there and it's going to go find a place where it can reignite. Well, it's kind of the same thing here. If it's burning, it's consuming those gases from the thermal runaway. But if I put that out, it's not stopping the thermal runaway. The gases are still there. I still got that problem to deal with. And the suppression system actually created a lot of issues. You know, there's been some news footage out of California. I don't know if anybody's seen it or if that'll come up in public comment. But that was a very old system. It was literally a warehouse that they put shelving into and stacked lithium batteries in there and called it a storage system. And it was from a long time ago. It's an occupied building. It has to have a sprinkler system. Sprinkler and lithium don't play. So the fire happened, it activated the sprinkler system and it flooded all the batteries with water. And it was a huge event because of, they just didn't know back then. The energy storage system has to incorporate things like smoke detection, flammable gas detection, and audible visual alarming. The thing about these systems, and NFPA and UL recognize this is what we call lagging indicators. If the smoke detector is going off, it means something has burned and produced smoke, or dinner's done at my house. Okay, that's a lagging indicator. The combustion is already occurring. The same with the gas detector. It's a lagging indicator. The battery is already in a problem and it's giving out gas. But we still have to have these systems. And so these battery modules do have smoke detection, thermal runaway prevention, and almost all batteries now are using the NFPA 69 method of control, where they can open louvers, turn on fans, and then seal the box back up when it's not needed. And then the other standards that cover lithium batteries. And so the UL 9540A test builds upon NFPA's 855 standard. And this is the standard for test method for evaluating a thermal runaway fire propagation in a battery energy storage container. We didn't have this prior to 2021. And I'll kind of walk you through this. It starts with the number 1 box, which is called a cell level test. And this is where the manufacturer will attempt to initiate thermal runaway in 1 cell out in the open. And almost nobody can pass that, right? It's going to go into thermal runaway if we make it hot enough or force it. But what they're doing in step 1 and 2 is they're collecting the products of thermal runaway and combustion so we can quantify what those materials are and how much it's going to give off. In number 2, they do the module level test. So they've taken the cell, if you think back to that slide, they've put it into the module with all the controls, the sensors and everything in its container. And again, they initiate thermal runaway inside and they look for containment. Can it contain it? And is there any non-flammable gases that are now being vented? In box number 3, they call this unit level test. This is where they're going to look to see what kind of spacing we have, what kind of temperatures are we dealing with between the thermal barriers. Will the thermal barrier stop it? Looking for no explosion, and then the heat flux acceptable. And in box 3 and box 4, and the types of battery storage that I've shown in the slides, they're kind of done together. But they'll do number 3 first and let it go. And then they come back and they'll do number 4. Number 4, the only difference here is we can actually use our mitigation controls. In step 3, we really can't. They don't allow us to. They want to see that worst case scenario and know that the unit can still contain itself, even if everything goes bad. But in step 4, we can use our mitigation strategies. Now, you remember I said smoke detectors, gas detectors, what kind of indicators are those? They're lagging, right? So what NFPA 855 and UL 9540A have said is, look, it's better if we act proactively. We know data. We have tons of data now on systems. We know what the key indicators are that tell us a cell is going to be distressed. And so when I say the mitigation strategies, that's where we detect the thermal runaway indicators, and we're actually allowed to use our controls to disconnect and isolate and do everything that we would normally do when the system's in operation to prove that it does work. And you can kind of see the configuration. They'll put the initiating unit in the middle, target units around it. And these are pretty cool tests. I've seen a video for one of the manufacturers that did this test live. It's $250,000 to burn one up, and they'll burn several of them to get their certification to prove that they're safe.
Tom?
Yes.
You said gas is a number 2 there where the gases are burnt. What gases are they?
Typically, it's going to be hydrogen. A little bit of hydrogen coming out of the vent.
Is there any danger of like the lithium and that kind of thing burning up, or how?
No, not typically. In the modern BESS system, they're getting that isolated and shut down before that can happen. And then if it did happen, it's still going to be isolated into the rack. And the deflagration will vent as it needs to, and it just
Yeah, it
disperses.
still has to go somewhere. though,
Yeah,
right?
it'll just disperse, just like the smoke in
So
a house fire.
poison, what kind of, we can expect of that is a poison, I would assume?
Well, it contains the same kinds of chemicals that smoke in a normal, like a house fire, a plastics fire. It's essentially a plastics fire.
Okay.
So the same kind of products. that we-
Carbons and that type of thing that in a house you.
Yep, carbon monoxide, hydrocarbons. If anybody still burns trash in a burn barrel, same kind of stuff.
So I'm leading you to believe that if the battery's sitting there doing its job, it's inert. There's no gas giving off, there's no lithium giving off, there's no sulfur giving off, there's no any of that other. It's just anything it does, it may create heat, and that's why they open it up. Nothing but air, really, ambient air would go in and out, right?
Right, through the environmental control system.
So-
Normally, the deflagration only
So
comes.
there's no real. There's no way, the way these are designed, then just to leak out whatever the lithium or whatever, heavy metals or whatever into the air.
No, because the containers themselves have to be the containment system. Under normal operation, it's not releasing anything into the air. It's charging a battery, it's decharging a battery. So think about it like this. So most of us probably have cordless tools somewhere around the house, right? We all have a cell phone in our pocket. It's a lithium ion battery. The battery in this laptop's lithium ion, right? We're surrounded by this battery technology, but at a smaller scale in our everyday life. And I mean, if I smelled my cell phone starting to make smells, it's gonna get chucked outside, right? Like in an airplane, the reason you can't check lithium ion batteries in your baggage is because they can't get to it in the cargo hold. And every aircraft has an isolation envelope in the cabin somewhere, and it's the size of a large laptop, because the protocol is get whatever is in thermal runaway emitting that gas, throw it in that sleeve, close it, and isolate it until they get the aircraft on the ground. Here, we will proactively try to prevent that, just like our cordless tools do. Has anybody ever plugged in one of your cordless tool batteries and you get this weird flashing pattern on your charger and you wipe off the label to read what that meant and it says battery's bad? That's because the charger, which is kind of like our inverter, and the battery management system inside that battery are talking to each other. And if the battery says, I've got a problem, it's telling the charger, don't send me charge. And it's just not going to allow it to charge. Where we get into trouble as humans is my charger's bad. I go on Amazon.
Yeah.
And I like cheap. Cheap isn't necessarily good. I buy a cheap charger, I put it in, it's not made to talk to that DeWalt battery, or I shouldn't say the manufacturer, I guess. And that's where we can get into trouble. So.
We're talking about reliability. You talked about a lot about this is what they do, and
Mhm.
so let's say we have an array. An array would probably be 6, 8, 10 of these in a row, whatever we call for that particular situation to keep the energy up in that area, whatever it is. So what would be the odds then of that array having one out of that array to have a problem? What are those odds?
I can't, I mean, it depends on what we define as a problem, because
I'm talking about burning, all of a sudden the fireman gotta go up there and there's nothing, they got a problem, they gotta stand there and watch it burn.
Worst case scenario.
yeah, very low, but I don't have that statistic in my head.
Less than 1%.
Probably. I mean, if you look at,
I mean,
yeah, I mean, if you look at, we've got, I believe the one company that I do the first responder training for, they've got 29,000 megawatts of deployed battery across the United States, and they have 0 thermal events. So I don't know how many thousands and thousands of battery containers that is, but we could do some quick math. But they haven't had any events.
Good.
So it's not.
So you're,
not-
so on the reliability side, they're basically, the way they're constructed today, they're just not gonna have a problem.
That's the intent. That's why they're doing everything that they're doing. It may have a problem, but you may never know that because the systems notify the
I'm
operator.
talking
Yeah,
about a catastrophic event that
right.
neighbors are gonna have to be evacuated or whatever.
It's pretty low. But I can't put a number to it for you. I'm sorry.
I'm just, I'm thinking about all the bad things that can happen.
Yep.
Because when we go to write ordinances and do things, we gotta think, well, what happens if it really goes bad or whatever, to be fair to all concerned.
Yep. And one of the things that is done in a project plan is called a plume study. So one of the things that you'll want to address is as you move forward into a potential project with the developer is once that technology is identified, because there's 3 or 4 manufacturers of batteries that have domestic content now. So most of the developers are using them. They're not going to China and all these other places. So depending on the technology, there should be a plume study available. And the plume study is that worst case scenario. So everything has gone bad. It's doing the maximum amount that it ever physically could. And this is what the plume will look like depending on your winds, your speeds and humidity and all of that. It's all factored in.
Mhm.
That's done through a.
So that plume study then would go help to say where should this battery array be placed?
Yeah, it's typically used in the permitting process. To decide whether or not that section of land should be permitted or
Okay.
things like that.
So the plume study would come before really anything else could happen. Is if it was sitting there, what would happen? Is that what you're saying?
The plume study is part of the project planning.
Yeah.
Yeah, and so it would say the plume studies that I've seen, they'll look at the proposed site plan in the permitted area or where they're proposing to permit. They'll pick the container that has the absolute worst possible scenario. So maybe that's as close to the fence or whatever the case may be. And they'll say it's burning, right? And this is what we would expect to happen with the smoke, the fire, everything else that goes on. That's part of their planning due diligence. All right, that's a great question.
I have a question.
Yeah.
It's probably stupid, but it's fine.
No stupid questions.
So if there is a thermal event, you said that with the actual lithium-ion battery itself, it's rare, but if it does happen, is it contained to that rack per se, or more likely to be contained to that specific rack?
Yes, if the battery system has passed the UL 9540A live burn testing, that's the purpose of that certification. Is they are proving that that design will keep it contained within the rack and the container.
So even if something does happen, it could still be contained to one rack out of, say, 8 within
Correct.
a unit.
Correct.
And those other 7 would not be affected necessarily?
Right, but they wouldn't just go in and fix that one. They would just replace the container and have it recycled. Yeah. It's a great question. This is what one of the battery modules look like under testing when it is off gassing because there's a thermal runaway event. Thermal runaway happens when there's an internal problem to the battery, and it could be a short circuit, it could be an overcharge situation, things like that. And so what NFPA 55 and UL 9540 have said is it's better to act proactively here. Now, the gas detectors that we looked at earlier are located in very close proximity to the vent on each battery module. So they get a real early indication that something's happening. But even prior to that, the sensors and everything else that's inside monitoring that have already triggered actions to be taken by the management system. So in summary, modern BESS is driven by very robust standards and codes, and it's highly regulated. It's a power producing entity, right? They're generating electricity for the electrical grid, so they fall under a lot of federal regulation on how they operate it, cybersecurity, site security, as well as required maintenance intervals and certain testing and things that must be done continuously. The modern standards and codes were developed from the lessons that were learned in older technology. We looked at one of those. We're surrounded by lithium ion batteries every day in our consumer electronics. I can't, there are events that happen in consumer electronics, so, striving for a zero is, I don't know if it's possible, but we're getting close. And manufacturers of the equipment have to comply with these standards and these manufacturing methods, or they risk the liability and the loss of their business. And the developers know this, so they're demanding that the manufacturers provide all testing and certification data to the project developers so that their engineers can look at the results. And the benefits then of this of battery storage is we get better grid reliability and capacity, less wasted energy, and we make more efficient use of our resources. But it also helps renewable sources contribute to our overall grid generation more effectively. Less reliance on traditional generation sources, and it is designed to be completely recyclable at the end. They can recover all the lithium and they'll make it into something else, some other battery. The lithium isn't consumed. It's the electrolyte that actually wears out over time, but the lithium is 100% recoverable. And these things the containers themselves are designed to contain the event if one were to occur to prevent large scale site contamination. Okay.
Okay, so I have a few questions that I think you can address, and then from that point, if anyone else has their own questions, just feel free to stand up. No pushing and shoving. I know you're all excited to talk, just one at a time. And again, the microphone is here on the podium. So one of the questions, and this relates a little bit more so to the unit itself, is stray voltage a concern with these units? I don't know what stray voltage is. I just know it was brought up at the last meeting, and how that might affect where we put these units themselves.
No, so there's no stray voltage isn't an issue. If voltage isn't going where it's supposed to go, the unit can detect that, it will shut off. These all have like ground fault circuit detection and things like that. If you're talking electromagnetic, they're designed to comply with FCC requirements for that kind of an emission, just like every other consumer electronic product is.
Next question, I know you said you've worked with, or a few different manufacturers. Do you know the average sound level of these units, in terms of if it's a 20x8 structure that it would give off?
No, but I do know that many ordinances require like 45 dBA at night, 50, no more than 45 and no more than 55 during the day, and they're complying with that. So I have to assume that they're at that level. I haven't been party to a sound study yet for
Yeah,
a battery.
that was one of their suggestions, was a nighttime, daytime level, and it's good to know that A, we're not the only ones thinking of that, but B, that the units that are coming through are complying with those, so that won't be an issue for us. Another question, and this might be more in terms of your safety training, is say there is a thermal event, and you guys have to do what you're trained to do. Is groundwater affected by runoff at the end of these events?
So this is where my friends and I in the fire service have to kind of change the way we think. It's so ingrained in a firefighter from the time they go through the academy, put the wet stuff on the red stuff, right? But has anybody heard of PFAS? Yeah, we all have, right? We're all affected by it. PFAS forced the fire service to really think about their runoff. And it doesn't matter what kind of an event it is. If we're spraying water, the command officer is already thinking about the DEQ report, right? I got one back here that could probably vouch for that. And so one thing that we know is that water isn't very effective at putting out a lithium ion battery. And we talked about reasons why we might not want to anyhow. And so with the new standards taking the more proactive approach, part of the training that I normally do, which is for the first responders, is we don't want to put water on that. We don't want to create a runoff situation. The container itself will contain anything that's inside the container. Even if all the, whatever it is, leaks out, it's contained within that container as long as we don't mess with it. But if the fire service were to come in and say, well, I got an exposure problem, I'm going to spray water, that's not needed because UL 9540A is the testing that tells us the spacing to guarantee that it can't move from one to the other. So there's no reason to spray water there. So runoff shouldn't be an issue because we shouldn't be creating runoff if everything is being done properly.
And then last question before I turn it over. Can you give us a brief just rundown, and you've kind of touched on it already, on what the safety measures you do train our local service staff on? Like what's the difference between these units that you have to kind of ingrain into them versus a normal house fire?
Well, it's not much. So let me back up. So when we do training for the first responders, we are talking about the physical hazards of substations, right? We're reminding them that there's high voltage. We're reminding them of their SOPs or their standard operating procedures around substation incidents and why we don't normally just cut the gate and go in, right? So we're just making them aware that those are the kinds of hazards. They're the same hazards that are associated with the battery system. The difference then is that we have to remind them that even once the utility says the system is de-energized, inside the battery container, it's a battery. It still has voltage. And so that's a little different from the way we've operated normally in the fire service, where the utility comes in, the power line was down, we're a span on each side, we wait. The utility shows up, they shut all the power down, they tell us it's safe to go, and we go do our thing. Here, we're going to work closer with the utility or the operator in conjunction with them. So that's one of the major differences, and we go into a lot of that with the fire service.
What I'm hearing you say is, I'm trying to figure out the right words, because if it's self-contained, it takes care of itself, when would the fire department be called?
Well, there's a lot of reasons why we would still want the fire service there.
I don't know.
It's going to be a nice call for them because they're going to establish a perimeter and protect the public.
And monitor probably.
And monitor and be eyes and ears for the operator on the other end of the phone. So another thing that the fire service gets is once they've gone through the training for two of the energy companies I do those trainings for, they get a special phone, just like they do for consumers or D or whoever's
So
around.
more than likely, the energy company themselves would create a call to the central dispatch, call the proper, they would take the initiative to call the service because nobody else is going to know that.
Yeah, that's typically how it unfolds, is the operations control center is usually the first to know that there's something going on. They have procedures and protocols that are mandated. So yes, they are typically the first person to contact your local dispatch or your county dispatch, inform them of what's happening and what they need. And usually they will ask for the fire service in these projects because we've gone in and done their orientation and training. They know what we expect. So they'll show up, they'll establish that perimeter, and they'll start feeding us on-site intel from a safe distance.
With going on that, so your person monitors it, where are they monitoring across another state?
Typically, yeah, typically.
So we all know how technology works and communications work.
Mhm.
Fiber line gets cut.
Mhm.
They have no idea. I mean, is there a fail safe to alarm them? Alarm 911?
There's typically redundant systems
Okay,
of
so there are some
communication.
redundancies of communication besides just that direct connect.
That's right.
There's maybe a radio or something, frequency rate.
Some of the things I've seen are like cellular based backups, satellite. I know Starlink is becoming a big backup now for some sites
Okay.
that I've been on.
Mhm.
And so, yes, there are, and again, because they're a power generator regulated under federal law, it's like our nuclear, there's so many different things that they have to prepare and plan for and show contingency for. So yeah, they avoid single points of failure.
Okay.
Yeah.
Yes.
Yes.
One more question. So there's an event. And central dispatch is called. And then whoever's fire district that is, they would be called. Then what other things would be typical? In other words, the energy company themselves would have to be sending people to take care of the problem.
Mhm.
The fireman's not gonna take care of the problem.
Correct.
So how long of a time span could that be?
It's typically not very long. Most sites that I've been on or I've done presentations for, they have a local site manager that's somewhere local to the community within 10, 15 minutes max usually. And there's usually technicians because, you know, if they get a fault that the monitoring center sees during normal operation and they shut that particular battery cell down, they're gonna dispatch technicians. The technicians will show up and go in and test and look. So it's not like they're gonna hop on a plane and be here in 2 days.
So it's similar-
Somebody local.
So it's like similar to like a Warren pipeline that had a leak here last winter. That we got a site manager who lives right in Elma. Yeah, he was there in a few minutes. Is that what you're trying to?
Yeah.
Is that what you're saying? They keep people around the area?
Yep.
So that they can come in and handle it almost immediately.
That's correct.
All right.
Yeah.
I think that was some questions that people were concerned about.
Yeah, and that's typical. I mean, I can't speak to what would be done in this particular case.
It's a rural area, so you gotta wonder, you know.
This isn't rural. Where I was earlier this week was 2 hours of driving with nothing but cows.
Yeah.
So that was rural. Anything else? This is like really good questions. I enjoy the discussion.
You want me to come up there?
Yes, please.
Can you hear me from here?
I think they need you to come up and.
You gotta speak into the microphone. I know it's hard.
I'll share with you.
Tim Gustavson, I'm local here. These batteries and everything, I believe, are doing amazing, up till now, we're doing an amazing job with technology, and I know it's getting every day, there's new stuff coming out and better and better and better. But my biggest concern, or one of my concerns, is why do we have to put this in residential areas? You know, why can't this be where the big substations are or something like that, instead of putting it in some farm field in somebody's backyard? Your first comment's probably gonna be, it's gotta be close to the source. Well, them wires push stuff all the way across the state, so that don't wash with me. And my biggest concern, you know, you say we aren't gonna have fires. If we do, it's this and that, but it's gonna happen. There's gonna be fires. And is there anything in these things that will contaminate the ground or the streams or the water down the road that we don't know yet? Thank you.
Well, thanks for the question and the comments. I can't, and I'm not going to speak on where you should or should not put them. That's for your ordinance teams and people to work on. I'm not aware of with the developers that I've worked with, I'm not aware of batteries being put into residential subdivisions. The projects that we deal with are utility scale. They are out as part of a large solar field or a wind farm. As far as runoff, if and when there's an event, right? I'll say that. Again, that's why the standards have been beefed up to the point where that container has to prove that it can contain that and not allow it to get out. Now, that's just one layer of protection. When they build the facility where they're putting these things, that's also an engineered system of containment. So there's gravel, there's all kinds of things that are done, just like in a typical substation, where anything that could possibly happen in there has to stay contained in there as far as water.
I know the company has done everything they can, dotted their i's and t's and this and that. But unless you can stand there and say, it's never gonna happen, then where does that leave us, you know?
Well, I mean, I can't say that something is never gonna happen. I don't think anybody can responsibly say that. What I can say, and what I've been trying to make everybody aware of, is that the standards are very robust. They are constantly being reviewed. The NFPA really took the lead on this thing, and they partnered with Underwriters Laboratory. And these standards are under constant review and update. Most standards, because I've sit on several standards committees, most are reviewed every 5 years, right? But there are some standards that due to the changes in technology or such are almost under continuous review. And NFPA 55 is one of those. And we're reaching that point where we're collecting so much data from well-operated projects that we know what needs to be in those standards. And if it's not there, they're adding, right, every day. And the manufacturers have to update to that if they want to get the certification for the developer to buy that product. But that's, I can't say never.
So can you say that these don't have to be in somebody's backyard or the next adjoining property? Can they be way down the road somewhere?
Again, that's really outside my purview. I don't deal with permitting and things like that.
But with your advice right now, these townships and communities around here could use that information when they say, yeah, we're gonna put it in this next lot right next door. They could go somewhere else.
Well, the ordinance.
So I think so basically to answer that question, so in terms of how these units are built, so say we have the substation over, I don't know what township, I know we have a couple in Gratiot County, but say we have one in Pine River Township. I don't know if you guys do, but I'm using you as an example, Kevin. Say you have a substation there, and then obviously there's farmers, there's local residences that live within the agricultural district, not necessarily a residential district. But it's a substation that's whatever size it is. But say there's a larger substation that's 100 miles away. Would it be feasible or possible with the current technology to basically connect our solar farms here to that larger substation and battery storage units over by the larger substation that's, say, down in Lansing or down by Lansing, not necessarily around people?
I know what you're asking. The problem is it's a very complex answer because there's federal regulatory requirements that dictate certain things too. So the feds will dictate and mandate where an interconnection can and cannot occur, and then there's capacity online. So one of the early things that has to be done to address your question about can't we just put it over here? I don't know, because what has to be done first is we have to make sure that the federal regulatory would accept that. And then secondly, yeah, it's a lot of times it does, right? But secondly, they have to do what's called a capacity study to know that all of the grid components between those 2 points where we're proposing could actually handle that, right? So that's why I say it's really complex. I know what you're asking. I just can't answer that because I just don't have enough information.
Okay.
I'm sorry. Yes.
Hi. I have a comment and then a couple questions. And I had to rearrange my comments because I wasn't sure who was going to be here tonight and who I was addressing. So in my perspective, and I think many other people's perspectives, is that any amount of battery systems creates exponential possibilities of fires and hazards. We have to assume that if something can go wrong, it will. These systems will be in place 20, 30 years or more. The likelihood of an event happening is very high. For instance, the Moss Landing fire, which you mentioned, it serves as a clear example of how toxic fumes from lithium-ion battery fires can spread. The dispersal zone was 5 to 10 miles in that instance. Given that the United States is currently ranked #2 in the world for incidents involving battery storage system fires, what measures or how can we hold companies accountable to ensure that installations are properly regulated and equipped with advanced fire suppression systems to prevent incidents? My first question. The second one, you mentioned cybersecurity. Given that China plays a dominant role in the production of battery cells and other critical components used in battery energy storage systems, what are the potential risks that a nation with adversarial interest to the United States could deliberately insert vulnerabilities into the system once it is installed on American soil? Could cybersecurity threats such as malicious software or hardware manipulation be introduced through these foreign-made components, potentially allowing an adversary to disrupt or disable the system remotely? And you might not have the answer to that, but that is one of our questions. I've got many more, but I don't know if this is the right place to ask them, because there are also human rights issues in the components that go into these, the mining. And so,
Well, I think I could probably take care of some
okay,
of
all
that.
right,
answering.
thank you.
So let me address your second question first. So the energy companies that I do training for, they are using domestic product. Okay. There's a lot of reasons for that, right? But the infrastructure acts and things that came out that provided a lot of funding had a domestic content clause requirement in them. And so we have started to see more and more onshoring of manufacturing of these systems. And in fact, I think LG is building a large plant to assemble or to do these materials, or these batteries. And so, yes, cybersecurity is an issue. You understand that our water supplies are under attack every day, right? That our power grid is under attack every day. There's hackers, there's, ill players out there every day. Your cell phones, everything is being hacked, right? So again, at the federal level, there are very strict requirements for what we call NERC certification. So for instance, for an employee to even walk in the front door of a power producing facility, whether it's a wind farm, solar field, gas generation plant, they've had to undergo background checks, drug testing and screening continuously. They have ID badges on every door now that identify when the person's in and out. Keyboards are monitored for keystrokes. Everything is being beefed up, right? And along with that is the technology that's being purchased to put into these sites. There's what we call no buy lists, right? There's certain components that we shouldn't be buying. And I won't name them here because this is a public forum, but if you want to know which routers you shouldn't put in your home, I can tell you, because they do have that kind of stuff in them. Remember the Huawei thing a couple of years ago? That's where that concern of yours comes from. And it's a valid concern. And that is something that is taken into account. Absolutely. It has to be.
So it can be hacked. It will be hacked.
Well, I think we're at this point now with technology where it is. You're right. If it can be hacked, it will be hacked. Anything can be hacked, right? It's just we keep putting more and more layers of difficulty into that. There's a whole nother, if you watch, there's a YouTuber, Vertesium and those guys, they talk about quantum computing and why there's so much data theft now of people's personal data, because the quantum computer will be able to crack that encryption in a matter of seconds, where the current computers take years. So they're buying it up to store it. Now, your first question, remind me again. Oh, Moss Landing. Yeah, you're right. It was a battery storage facility. And I openly addressed that. It was a warehouse. A repurposed building where they stacked a bunch of batteries in there. That is not what we're talking about here. We are talking about purpose-designed, self-contained units built to a robust set of standards and codes. Okay? Moss Landing was horrible. It was probably the worst thing we could have ever seen, but it was done because when they built those systems years ago, there was no standards or codes for anybody to really follow other than the local jurisdiction for fire safety, right? And unfortunately for the fire service, they were put in I just met with the California State Fire Marshal a few weeks ago. The fire service was put into an extremely difficult position in a lot of those cases where they can only enforce the codes that are in place at the time. Right?
They need to put in good quality codes.
The codes and standards are there. Right? It's your commissioners can reference those things and they can influence, the developers and so on. And I'm not, this is not for me to tell you how to write or what should be in an ordinance, but those things exist. And that's why I was here tonight, is to make you aware of those standards and codes.
Do you want to live next to one of these battery storage facilities?
I haven't seen one right next to a house in all of my travels, so I can't say. Now, I will say that next to our offices, there is a battery storage facility for a solar field that's there. They've got, I don't know, 4 or 5 containers and an inverter there.
Do you know of any address or location in Michigan where we can go and look for one ourselves? To see what it looks like in person?
Not off the top of my head. I could probably find one, but again, it's super secure. I don't know how close you can get. A better way might be, you know, as a county to ask, who's your utility here? Consumers, maybe ask consumers or somebody, if there's a possibility that you could go visit one, because I do know that they do that stuff. I've heard of other groups going and actually visiting things like a wind farm or a solar field, or I know in Wisconsin they do, because I work with a company over there and they have a community tour day. Yeah. Yeah, welcome.
I'm Roger out of Canova Township. And it just happened to be ironic that I was at the Michigan Safety Conference this week. And they had a nice ion battery. And a lot of what you say is true. However, the speaker there, kind of like he put it, we're still in the learning phases of the thermal runaways. That like they had the one, they learned more things from the thermal runaways. And I know you can't say it can never happen.
Right.
Because once it starts really quick. It goes fast. It isn't like something at time. The fire department, most likely, it's going to be over before they get there. And, you know, because it's such a large amount on that. And they're having not only issues with the big ones, they're having issues with the cars, the e-bikes we were discussing, and how the charging issues and people are doing it inside their homes. How quick that they actually do, which is the same thing, except for this one's bigger. And the codes, yeah, you're right. They have changed and they have made new things, but like they kind of told us, we're kind of in the middle of the technology. And they're still going to be learning things. And if you put one in now and they change codes later, are they going to change and update to them, or is it going to be grandfathered into the old system? That's some of the concerns, because they're still learning in the industry, is kind of what I was taking from this. And there was a lot of big concerns with the cars coming in, being in the, you know, the garages, burning the houses down, because there's really nothing you can do to stop a thermal runaway.
Right.
And if it happens, I know you were talking about a lot of the things, that was, you know, the biggest thing. The pollution in that, it's a normal fire. But it happens, what I was taught, very quickly.
It can.
Very little, you know, and basically it's because the plastic in the cells melt, and you're allowing the charge to be able to go quicker and because of the heat. So I was just kind of trying to address that, kind of let him, I know some of the questions you would ask, some of the things that I had picked up. So if I was wrong or misinterpreting anything, I'd love it, because I found it very interesting. Not only for this big one, for your little ones that you have to deal with, and how we really don't even have a proper way of disposing them set up. It's not a common.
It's cumbersome. Well, for consumers, it's cumbersome.
Yes.
For the battery energy storage system, there's companies that take those. So that's pretty well.
Right. But it's just, there is a lot of things to address and to work with the fire rescue on that part. So that's all I'm I know that, you know, like you said, they do have new changes because they learned.
Mm-hmm.
But it was kind of told us they're still going to learn more.
Well,
As
absolutely.
it goes through, because
I think that's-
our technology is kind of in the middle ground, and, you know, they haven't come up with anything. They do have safer stuff, but it doesn't work as well. And I know that some of the stuff that they kind of been working with. So that's all. I think thermal runaway is a big concern. As far as needing it, but anything, we're probably gonna have to deal with that, but the thermal runaways is protecting people.
Yeah.
That's my concern. So,
Well, thank you for your comment. And I can actually, you're spot on, right? That a lot of what you heard at that conference is the same stuff here.
Informative, you kind of broke it down on how thermal, happened.
Yeah.
And then kind of, you know, they kind of put it into small homes and how it rapidly.
Yeah.
It goes, there's really no warning and, but.
Well, see, that's the difference though. That is one difference, right? Is with a household system, we're relying on automation within the unit to let us know there's a problem. Whereas these systems, there's a system operator dedicated to be watching that. They're looking at the cellular level for those key indicators and they're shutting things down because. Yeah, well, it does and it doesn't. I mean, there's a lot of things that happen before it actually goes into thermal runaway. It's very difficult to actually put one into thermal runaway for the testing. They have to almost melt the battery to get it to do that. So there's temperatures, they're monitoring the temperatures continuously. There's pre-programmed alarm points for actions to be taken by the battery management system to stop the charge, disconnect, you know, all of those things. Now, what I will say, and you're correct, we are still learning about thermal runaway, but we're learning about how to prevent it.
It's already in there.
What we've already done with the new standards and codes is how to contain it. Right? And that's proven effective. So yes, as we learn more and more, you know, 50, 100, 2,000 years or however long we're around on this planet, we continually learn more as technology advances. That's with anything. So yes, we will learn more. As far as retrofitting and things like that, I can't say. I don't design them, so.
I understand.
Yeah.
You're kind of helping out a little bit.
Just kind of an understanding.
It was kind of a very similar presentation, but it was more about, you know, for the fire departments, what they need to watch out for. And they discussed the bigger ones and how they do fail and what does happen. You know, there isn't really a way to stop.
Right.
They can't be explosive.
Well, these battery modules don't. That's the whole thing. They're NFPA 69 or 68, whichever strategy they're using, it has to prevent that. And they have to prove that through worst case testing. They're not going to just explode.
Everything started with like e-bikes because you charge an e-bike outside, you don't have an e-bike anymore.
Yes, I lose sleep.
For your bedroom.
Yes,
You might not have a house in the morning.
that's right. I lose sleep over consumer rechargeable batteries. Right? How many fires have we determined cause in Orange? Lots, you know, across the state and the nation. You know, e-bikes, I mean, oh my goodness, right? People don't realize that, you know, like if you crush one of your batteries for your cordless drill and you damage that thing, that should be properly disposed of. If there's damage to it, I don't care if it still works, you don't know what has happened internally, right? But that, you know, those are the things that keep me up.
Outside.
Yeah, exactly. You know, in our manufacturing shop where we build all of this different equipment and stuff, it is a policy that the last person out has to make sure that all rechargeable batteries are removed from the chargers. The chargers are unplugged. We will not leave a recharging battery on without anybody there. That's probably because I've been ruined from the fire service, but you think about it, right? There's nobody monitoring it. These systems are monitored. We're shutting things down. We're doing things. Great points. Thank you.
I just want to add a little bit to that.
Yeah, no, it's great.
Appreciate it, Roger, yeah.
I kind of picked up a few things.
Yeah, good.
You know, they haven't been timed and good, so
I appreciate it, Roger. Good.
Love it. Oh, I'm sorry, I got one right here. Can I? Okay, I'll come right back to you.
Yeah, I'm Peter Sinclair. I'm from Midland and I'm trying to learn more about all of these issues and your presentation is phenomenal. Thank you so much. I wanted to address the lady's concern about human rights issues, which I think is a very valid one. The big concern that a lot of people had a few years ago was the use of cobalt in a lot of the batteries and the human rights issues with the sourcing of that cobalt. Am I right that the lithium iron phosphate is pretty much the standard now? Okay. So those were the nickel manganese cobalt batteries were the standard 5-10 years ago. We have moved to the lithium iron phosphate batteries as the majority of the standard now, which contain no cobalt. and no nickel, which is another problematic mineral. And eventually, I think we're going to see more and more like sodium ion batteries, which sodium is one of the most common elements on Earth and very easy to source. And then down the road, the major battery makers are telling us that by the 2040 timeframe or so, they expect the entire battery industry to be more or less circular, where they will have little or no mining, whatever. And so I think, we're seeing things get better and better and better as we move down this technology curve. What a lot of people don't know is that one of the biggest uses of cobalt historically over decades has been in the refining of gasoline. So interestingly, they haven't heard anybody complaining about ExxonMobil's abuse of the poor children in Africa to source that cobalt, and that continues even though the battery industry is getting out of that business. So, just some perspective to kind of keep things sort of balanced. We're moving away from the things that are more problematic, and the technology is generally getting better and cheaper and more congenial to the environment as we go forward.
That's just your opinion as far as it being better, because we have to live with this, the solar, the battery storage. We have to live with this stuff that we weren't expecting, that was being forced on people. And so if you know more about like the batteries, the sodium, where does that come from, the sodium batteries?
Seawater, maybe? I'm not
Do you have any examples of where these would be, or how you come to know about them?
They're being researched.
Oh,
There's
it's not
many,
being used.
well, there's small scale testing and things, it's not commercially in production yet to my knowledge. It's kind of a venture capital level thing. It's the next, the next big technology that we expect. But anyway, thank you so much. Really, really valuable stuff. Thank you. I promised to come back to you next.
Tom, you done a good job explaining, you had two means of communication with these units. What would happen if those two means of communication was shut right off 100% and there was no control? What would those units go through?
That's a great question. So remember we said that these have what's called a battery management system inside of them. That's basically a computer that's responsible for controls and operations and communications, right? So one of the things that happens, if it loses communication, it goes into pre-programmed shutdown and disconnect. It's automatic. It's not going to continue to operate if it doesn't have oversight. And that oversight comes through those communications. It's a great question. Thank you. Go ahead, sir.
Well, my understanding is there's a company in Missouri doing sodium. Is that correct? And it's on a large scale?
Yeah, I don't know how large it is, so I can't speak to my knowledge, it hadn't gone like commercial, like huge deployment yet. We're still in the lithium iron phosphate.
Pictures they show are huge.
Yeah, but I haven't seen it or talked about it in the battery storage projects that I've gone and trained the fire teams on yet. So I can't speak to it.
All over the internet. The other thing I gotta ask is, why is it Gratiot County keeps getting hit with all the power stuff when over where the Palisades plant is the nuclear plant? They're taking a quarter, no, they're taking a third. They're taking a third of the power that they're going to make there, and they're going to ship it off to other states. So that tells me that Michigan really doesn't need all this extra power at this time. But why is it Gratiot County keeps getting hit with the solar, the wind turbines? And whose pockets are we lining here? I don't want you to want to know.
Yeah, I'm sorry. That's just not anything I can speak to.
The truth of the matter is, some of the things that have gone on with our state, you're going to find that these politicians are able to take the money from the big corporations and to promote what the big corporations want. And that's what's happening right now in this state. I'm not gonna name any names who's got,
Yeah.
who's taking money or anything, don't get me wrong. So I can deal with lawsuits, and I think anybody in here that knows me know that I can do that. But I'm not interested in getting a lawsuit over that. But what I'm trying to figure out is why is it we're always one step behind everything that comes up? We should be with a better battery here for our people here. You know,
Yeah, I'm sorry, that's just outside of my scope of knowledge as to why Gratiot would be.
Yeah, so I can touch a little bit on that. So I mean, if you think about Gratiot County as a whole and where we're located, we're central Michigan. I mean, literally central Michigan. St. Louis is proud, got a little sign every time you drive through that says they're the center of Michigan. So there's that factor in terms of location, and then also the transmission line that's along, what is it, the south of our county?
And.
So when they put that in,
Soon to be the west,
and
north,
yes.
south.
Soon to be the west. So the location of that as well is kind of what draws the attention to Gratiot County is the location and accessibility. Another factor is the fact that there is the space for their plans that they want to develop. So those are just three factors to think of as to why Gratiot County is an attention drawer for these developers. In terms of money, I obviously can't speak too much in terms of the political side of it. But there's money exchanging hands in every step of this process, whether it's to the inspectors, whether it's to the local regulatory agencies when you have to pull a permit, whether it's to small example, when you're bringing in the laborers to work, where are they staying? It's typically local motels or hotels. Where are they eating? It's local places. So I mean, in every step of these projects, from the planning, the developing, the operations, the decommissioning in 15, 20, 30 years, there's money involved in all aspects. The large scale amounts that you're referring to, obviously no one can actually speak to it unless they're the ones who are getting it or giving it. But yeah, so yeah, that's kind of an idea as to why Gratiot County is being a focus for these larger projects such as wind, solar, and now battery storage systems. It's those reasons. It's where we're located.
okay, so I can tell you that everything that's been in an arena, like we're talking about here, those areas, the population is leaving. And it's happening all over the place. Their schools are starting to dry up all over Michigan. I mean, Michigan's got to be the dumping point for power going to Chicago. And that's what the new area that we're talking about from Kalamazoo over to Carson City, those power lines in there, those power lines. Okay, that's what that's all about. They're trying to put a big circle around Chicago so they can get all this power to Chicago. And we're gonna get stuck with a bunch of turbines that are gonna be obsolete because right now, the power companies, I assure you, are really looking at nuclear, really hard to put more nuclear, whether it's the safe nuclear or the other nuclear that we're actually using. They're really big on that because that's where the power is going to be. That's where the most power is produced, right there. And we're gonna get stuck with all the leftover stuff here, even though they put together things saying, well, you know, we'll take this down or we'll do this, but bankrupt companies in those sectors, they can't take them down. It's going to be like the oil wells.
Mhm.
And you know who paid for all these oil wells to be paid? You and I did. And they just finished them, as far as I know, they just finished, and they were down underneath 200 oil wells. But that's what happens. Consumers will buy the power for so long or own the place for so long, and then they'll sell it to somebody else. They'll run it for a little while, and then maybe somebody else will buy it, or maybe they'll buy it and just say, okay, we're done, we're bankrupt, and then walk away from it. And Gratiot County is gonna get stuck with whatever's in Gratiot County. Montcalm County will get stuck with whatever's there. And we're gonna end up taking this stuff back down again.
Well, thankfully, your commissioners, I know that the first wind turbines came in around 2012. Thankfully, they had the forethought to basically get the funds to remove these items in advance. So there is money that the county holds. What is it? Escrow, I believe is what it's called. Escrow and bonds.
Yeah, but it's decommissioning money.
Correct. And it's
And each farm-
specific for
each
decommissioning.
Section has different, and there's several of, every farm that was created has a decommissioning.
Yes.
That's correct. I understand.
We all had
They
them.
have a decommissioning, but the problem is when the power does not exceed what they can pay you for the decommissioning, it starts falling.
We've already been paid.
That's the thing is we already have that money.
Have the money.
So part of every new project, and that's one of the things that we have to implement into this new ordinance is that decommissioning plan is before they start that project, they give us the money to get rid of that project.
Okay, so.
Does that make sense?
To cover what it's gonna be 20 years from now?
Yes.
Yep, and that's the part of the plan and Commissioner Sopsey mentioned it at the last meeting. So there is typically a 5-year review on every decommissioning plan. And it's because, I mean, costs are increasing everywhere. We have an egg crisis right now. So they review those prices that were initially implemented for the funds. Mr. Sopsey or Commissioner Sopsey wants to increase that review to a 3-year review so that we can then adjust the plan accordingly as prices increase, say in 25 years, if these are going to be decommissioned, it can be afforded. It's not going to come out of the pockets of the taxpayers.
Man, if he's gonna go 3 years, because that's what it needs to be. But you're gonna find out that a lot of these wind turbines, a lot of these solar panels are not gonna make 20 years. And if they do, they're not gonna be producing very much power. It's not that nuclear is gonna take over necessarily, but it'll be a more improved. You know, could be solar panels improved, could be, now here's the other question. How many solar panels are we looking to get here in Gratiot County? How many would that go to with the amount of batteries we have? How many batteries?
I think one has to do with the other.
Yeah, one doesn't have anything to do with the other. They can put in a small amount of batteries or a large amount of battery. It's not like if I have X number of cells, I have X number of batteries. They're kind of independent that way.
So this is the way I understand it. Batteries have to do with the fluctuation in electrical system. And they only use those batteries when they have to make up something. That's all they're there for. They're a storage unit. They store energy until it's needed. That's basically what it is. So it basically flattens out the curve, in other words, so that you got equal amount of power across the curve. That's the object, the way I understand it.
And that's correct. I can slide back here to.
It's okay, I understand the battery thing.
Yeah, but
Yeah, that's what it's designed to take care of, right there. Where the actual demand has exceeded the generation. The battery could fill that gap for a period of time, up to probably 4 hours, depending on the size of the battery. But this is a pretty typical thing that we see. And you can see this time of day from midnight to midnight tonight. Everybody's asleep at 2, or most of us are, and then we start waking up around 6, and so our demand is going up. And they're forecasting that based on historical data. And so they can kind of predict with some certainty how much power we're all going to demand when we wake up, turn on the coffee pot and the lights and everything else. And so they make sure that they've got the generation for that. But if something happens, an ice storm, and a line goes down somewhere and they can't reroute power around it, in the local grid where we might still have power and maybe we have a battery system there, that battery system can come online to help make that up.
Well, how
So-
many batteries are you talking for Gratiot County?
I have no idea.
You know,
I'm not a developer. I'm just here to talk about what it is, how it works, the standards and regulations.
Currently, we have had interest or questions from 3 developers in terms of basically, do we have an ordinance or do we plan on implementing an ordinance, or are we going to follow the state ordinance, or do they have to go to the state to get permission basically for siting? They haven't necessarily produced any plans or anything because every time I've told them that we're in the works of developing an ordinance, But so far, we know that there's at least been 3 developers who have been looking at Gratiot County in terms of placing these units in.
Anything else? Yes.
If we have 3 developers, a lot of these BESS projects, they involve binding contracts under LLCs. So if it's not like DTE or Consumers Energy, that could put the county at risk of becoming a Superfund site in the future. So how does that get addressed?
What do you mean? Like if they sell it to a energy company?
And they go bankrupt.
Like if DTE went bankrupt?
I don't think DTE ever,
Oh, right, but just like as an example.
but like some of the other ones.
So if they went bankrupt, I mean, that's where the decommissioning, the escrow funds come in, is the developer is the one who provides those funds initially. So before they even get their approval where they can break ground, they have to have those funds to Becky, our accountant, and she puts it into a fund labeled so-and-so developer project, whatever. And then we know that those funds are specific to that project. So then once the project is up and running, and then these developers are like, okay, who are we selling it to? Who's the highest bidder? They could sell it to DTE, and DTE could go bankrupt tomorrow, but it doesn't matter, because if these projects need to come down, we can do that because we already have the funds. Does that kind of answer your question? Okay.
I do have a question.
Yes.
Can you explain that, okay, I think you said the batteries store 4 hours of energy?
Well, they're typically, most batteries are designed to contribute for 4 hours at their rated levels. Now, they won't always do that. Most of the time, like Commissioner said here, is they'll come on for a short period of time to make up a deficiency in generation. And then they go back to waiting for a little charge or waiting for the next time they need it. Kind of like that slide I showed you. But when we rate batteries, we have to rate the energy capacity or the quantity over time. And what could that be? And most are designed to do 4 hours at their maximum output.
Okay, so like if we had a localized energy outage for weather or
That's not gonna
whatever,
help us any.
that hour period for 4 hours, well, what's 4 hours?
I mean, it could. I don't think that's the intent. Because if you're out because of whatever, that's not what the batteries are designed to take the place of, right? They're connected to the grid just like every other generation source is. But they can bolster the local grid. So the best example, like I was just out in Nebraska, there's a lot of grain dryers that come on in the fall as the farmers are harvesting. And there was several people in my first response group that said, yeah, I can tell every time the guy down the road turns on his dryers because their lights dim and then flicker, and they're constantly seeing the results of not enough power on their grid. Whereas if they had the battery storage there, the batteries would come online quickly to counter that, and their lights would be right back to normal brightness again. That's what it's designed to do. It's designed to take the stress off of the grid by storing some energy and using it when it's needed.
So is that more important than keeping the community safe, having a little bit of energy? A little bit of 4 hour energy compared to keeping the community safe? Does that make sense?
I'm not. I'm not here to discuss that.
That would definitely be a good question, Sheila, for the lawmakers down in Lansing. I don't know if you have gone down there, if you plan on it already, but that would definitely be a question. If you were to go down there in terms of your human rights and safety, to ask them, or if you were to write a petition, that would be something that you would include in it, would be you're making these laws for siting control, but then where's the safety aspect that you could ask? At this point, we don't necessarily have that regulatory control in terms of saying we can't have them at all, or we're not going to allow them in here. At this point, we're at the terms of how can we make it as safe as possible for our area without causing any issues state level, because we don't want to deal with that kind of a trouble. You know what I mean? But that's definitely a good question to.
I just don't want to get away from the concept of what this meeting was all about.
Right. Yeah.
And we're starting to stray into other political things and other areas. I want to keep it And to the fact that we're learning as much as we can to make, make an informed decisions on ordinances pertaining batteries, these storage batteries, and that's what we're looking, go ahead.
Oh,
I had a question.
I'm sorry.
Some misinformation. You had mentioned that there's no gas emitted, and in my research, it spoke to 1.04 liters per 0.4 watts generated every time that battery cycles and recharges. So that's what the data is out there that is saying. However, you had mentioned that obviously there's an issue, otherwise they wouldn't have the remote monitoring for the gases and to release those fumes. And I believe you mentioned that when a battery malfunctions, it does emit carbon dioxide, hydrogen and carbon monoxide, as well as hydrogen carbon dioxide. And we all know that that's toxic to the humans. It's a benzene and it does create issues for an individual, depending on how close they are. And I worry about the fire hydrants because they're a heck of a lot closer than that in the atmosphere. They put emissions on cars and everything. This battery is just compounding those emissions. So I just wanted to make that a clarifying statement that these batteries do emit emissions every time they recycle. Because if they didn't, you wouldn't need a vent in those containers.
the vent is only in the event of a thermal runaway, which is not a normal operating condition. Under normal operating conditions, they are not emitting, otherwise they would consume themselves up. And we'd have to be refilling them, and we don't do that. It's not part of the process.
What's the literature say that these batteries?
I don't know what literature you're referring to or what context it was created in, so I really can't answer that.
Explosion guideline, 44-page document that's out there.
There's a lot of documents out there that may or may not contain pertinent information, but until we look at the context of our discussion, I'm not gonna fall into that. As far as other chemicals that you mentioned, like carbon monoxide and benzene, you're dosed with benzene every time you fill your gas tank.
I understand it, yeah.
So it's out there. I get that. It is a concern. But benzene isn't part of the process in the battery storage.
The storage, the emissions.
Yeah, he was,
Just an easy question. On the sites that you've seen, how far apart are these units when they're setting in whatever field? Or how many do they put on an acre or 10 acres? I'm just trying to get you didn't really have a picture. It looked like they sat right on top of each other, but
well,
not the way I understood them. So.
let me see if I can find. So the picture on the right is a typical representation of what that would look like. Okay, and so these are the battery containers, and there's typically a fair distance between them because technicians need to be able to go in there and open panels and things like that.
Are those the size of a semi-trailer or?
20 foot, a 20 foot by 8.5 by 9.5 shipping container.
Connex container, that's,
Like a, yep.
that's what I call them, a Connex container, basically what they look like.
Well, this is just a representation, just to show you kind of what something looks like, but there's more batteries, and then these are the inverters. So this inverter takes care of several of those batteries. It's not a one-to-one. And then there'll be other equipment like a transformer and things like that at some place within that yard.
Could we potentially have 100 of them in Gratiot County in one spot like this?
I
He doesn't regulate siting, so he can't speak to
can't
that.
answer that.
That's what would come in with the developers. So Mr. Sutton here could tell us how these are built and the safety with these things. He can't really speak to the siting or where we put them in terms of that. That's gonna be at the county level.
So
Does that make sense?
They could answer that next time we see them, I mean, in a meeting.
In terms of siting,
If that meeting specifically for this, yes, because I haven't studied it yet. I'm just learning that just like you are.
Okay.
I don't know.
Yeah, and you wouldn't know how many containers are gonna be there until a developer puts a design together that suggests this is the capacity that's gonna be used there. That would dictate the containers, and I don't I haven't heard that we're even there yet, but that's how that gets determined. Then it's between the developer and the county to determine.
As far as I know, no developers come to us even to say we want to put these in. This is an ordinance so that when they do, we were ready. We don't like to be behind the times.
Right.
We like to be with it.
Right.
We're a little bit ahead of it. That's what this whole thing is about, so we can be ready in case they want to come and do it.
One last question, this should be easy for you. You have a family, how close to those would you want to be living?
Sure.
I mean, with proper sighting, I wouldn't care if they were on the property next to me.
Okay,
I mean,
well, do you have a distance from your house?
well, again, it's gonna depend on the county's zoning and everything else and setback.
You personal, you and your family. What would?
I have no problem living right next to them.
You wouldn't have any problem living next? Okay.
Another question that kind of relates to that, and it was raised at our last meeting. One of the things that they wanted to include in the plan, so we have like, vegetative covers, fencing regulations. Another mention was a concrete barrier either around the entire facility, or potentially in between each unit. It wasn't quite clear. Would that be an extra barrier that we could add a concrete, like, when I say concrete barrier, I mean like a 4-foot thing to stop the spread in case there was a thermal event? Is that something that would help, or is that just
It's not gonna
something?
help. I mean, the testing and certification already says that they're not gonna propagate from one container to the next. So that's one of the whole purposes of UL 9540A is to validate that it can't
See,
propagate.
they run these up to failure. They make them actually burn.
Yeah.
And they gotta be able to stop themselves within the unit. If they don't do that, they don't pass and they can't do it. I mean, that's the way it works.
Yes.
Has there been any situations with the projects that have been built after, with this technology and using all these standards? Has there ever, that you're aware of, I know you probably can't speak to everything, but are you aware of any incidences that have occurred where it has gone from one container to the next, if it met these standards when it built?
No, not with these standards, but again, there might be some out there that I'm not aware of, so
Okay.
yeah, don't hold me to that, but I am not aware of it, no.
Ask you about the sound. Units, the inverters and so on and so forth. And does anybody put anything around them to keep the sound out?
The design itself incorporates some of that, and then it depends on where they're gonna be located and whatever the zoning and, what they decide can be acceptable at what distance. That would dictate whether or not there has to be something.
I think that what I've learned and what I've read, it's typically 55 day, 45 night as far as the decibels go. And that's standard.
It is, and I've heard that too.
Yeah.
I agree with that. However, I've also heard of places that put them in, found out that they were a lot noisier than 55.
Well, obviously, if they don't meet it, they can't put it there, can they? If the ordinance says 55, 45.
They don't, sometimes they don't know until they're in.
Once they're,
It makes the units.
yep, so once they're in, so that is addressed, so, and this is for any part of the project, not just noise. It also relates to how the structure is built, the fencing around it, that kind of thing. If there's any part of the plan or the project where after it's been implemented, after it's already operating, and all of a sudden my office gets a complaint like, hey, this is really loud. I think it's louder than what the decibels allow. At that point, we go to the developer or to the project manager, we're like, hey, these are loud, we're requesting a sound study. So then they have to do over a predetermined length of time. And they hire a third-party inspector that we have to agree on as well to then do a sound study. And then if it is not within regulations, then they have to bring that unit into regulations or it has to be removed. They can't operate it. So there are instances such as with the wind turbines where a few of them were louder than they needed to be, and we received complaints. I think we did 3 sound studies for 2 different units, and one of those units did not fall within regulation. So that one had to be updated or removed, and they did fix the mechanical issue with it, so it was brought back into standards. So it definitely can happen where after everything's all done and the last piece stone is down, that there could be something that's not within regulation. But that's where, after the fact, that's where our office comes into play, where we hear those complaints and then we make sure that they're answered. We're not just gonna say, oh, well, now you have to deal with it.
Okay, what sound study do you use? There's at least two different sound studies. Which one do you use?
I don't, it's recommended not by me. So we get a third-party inspector to do it. And it's just a third-party inspector chosen by the commissioners.
And it's done over several days, several weather conditions, and it takes almost a good month to do those things.
It's
That's not
2
what I'm
months.
getting at. What I'm getting at is there's different sound studies, different ways of,
You'd have to ask them, I don't know.
you don't know.
We hire a third party.
They're not the same. Just so you know, they're not the same.
So I'm sorry, I don't know you, sir. What's your name? I'm not familiar.
Harold DeFever.
Uh-huh.
Okay.
So, and what's your expertise?
I'm retired.
Oh, so, well, you had seemed to like a lot of knowledge. I just was wondering where you were getting the knowledge.
Well, I work for Total Petroleum. Just beating away and,
Oh, yeah.
I understand a lot of it. I don't know.
Well, you seem knowledgeable. I just was wondering where.
So that when you put it in the ordinance, you can put in this style of study that's in there. Otherwise he's gonna come back at you.
Good.
I'm trying to help you.
Question about the plume study, is it independent for containers to, identify the risk of exposure in an event?
That's the whole point of the plume study. That's right.
Okay, so our ordinance should mirror the potential dissipation of the debris
Sure.
from the system. And that occurs.
I can't speak to the ordinance. That's not.
Sorry, so what do you mean by mirror it? Like,
If the study says it'll go 5 miles,
Mhm.
then the ordinance should say that there should be no residents, cattle farmer, or however you want to word it, within that radius, so the risk of the mileage should mirror the ordinance
That's not heard.
geographical parameters in which you let them install there.
yeah, so that makes sense, except our ordinance wouldn't necessarily put that type of regulation on it. So the way the plume study would work correct me if I'm wrong, is basically when they're testing these units, at the end of the development of these units, the plume study occurs,
No,
correct?
before.
No, it's usually before.
From the permits.
Well, I mean, like the
Once
unit
technology
itself,
has been identified.
right? So once you know exactly what type of unit you're gonna use, which manufacturer you're gonna go with, they will basically put in, like I don't know the word I'm trying to use. They'll basically create a situation, probably on a computer, right? That will then mirror what that location looks like that they're planning to put it in. Say the corner of 57. So they're gonna put a unit there, and then they run through the system all the worst case scenarios of what can happen, and then we get the results back. At that point, it's specific to that area. Because something could happen down by 57 that might be different than 46, just based on the conditions of that area. So we wouldn't necessarily want to put specific regulations based on the plume study. We want it to be project specific. Does that make sense? So we would request the plume study before approval. We would look at what the results are, and that could be a determining factor in approval or disapproval of that specific project.
You're gonna find word in that, aren't you?
Does that make sense? Okay.
Okay. I think we've had a lot of good discussion. I hope that you go away knowing a lot more about, industrial storage batteries than you did before. I know I do. I'm a lot happier now than what I was before. And when I sat down to make a decision, I got some reference points. So, if you got any closing remarks,
That's it. Just thank you for coming and engaging in discussion. It's
DNA.
So for the next steps of this process, for the ordinance adoption, so there's additional questions, that are legal related that Mr. Sutton obviously couldn't answer, that we have to get the answers for the commissioners. And then once this meeting is scheduled, I don't know if you guys have signed up for it, but the county offers a notify me option specific to the Board of Commissioners meetings. So you just go on the website, you can sign up either via email or text, and then you basically get a text that tells you when these meetings are. And then I'll also provide a link to the agenda for that meeting. So I can't say for certain when this will be on the agenda, but if you sign up for those, then it'll let you know and you can check out the agenda to see when it is on. I can say it's probably not going to be the next meeting. I work fast, but I do not work that fast. And I do still have to get with legal counsel for some of the questions that you guys had last time. But that's just a way for you guys to keep notified. You can also obviously contact our office at Community Development. You can find us on the website, or our phone number is 989-875-5201. Need either myself, Kaylee here, Tony, or Bill can let you know at least when the meeting is and how far we are along in the process.
I think that's a wonderful thing that you've got going on, where we can sign up for that, either email or texting. It works great.
I cannot take credit. I think that was all the commissioners in our IT department, but it is great. I will say that.
Okay, all set.
Thank you, guys.
All right, thank you very much for attending. Appreciate it.